All right, everyone, welcome back to the Land of Chem. I'm your host and the author. My name is Jeffrey Drum. Thank you all so much for joining me again. All right, everyone, welcome back. This is episode 120, and today I will be explaining the activation and the application of ultrasound as a catalyst to facilitate the chemical reactions that were once occurring inside of the Great Pyramid of Giza. This episode is the culmination of the information that I have presented thus far regarding the function of the subterranean chamber, the grand gallery, and the acoustic catalyst antechamber. This is about to be a wild ride, so buckle up your seatbelts. And if you haven't already, please subscribe to the Land of Chem here on YouTube if you're interested in the technology of an ancient civilization utilizing physics and chemistry and the function of the Egyptian pyramids and other ancient structures from across the world. If you want to help support the channel, check out the Land of Chem members only section for exclusive research and unreleased footage that you will not see anywhere else, and thelandofchem.com if you want to pick up a copy of the book or grab some merch. If you want to follow me on Instagram, my handle is @thelandofchem. Also, don't forget, after you finish watching this video, please go subscribe to our two new channels here on YouTube, Egyptian Trash Cats for all you cat lovers out there, and Egypt Eats for food reviews. Ladies and gentlemen, as always, thank you all so much for the support. I think that's it for the intro. So without further ado, let's get right to it. All right, everyone, here we go with tonight's episode. And today we will examine the function of the red granite components inside of the Great Pyramid, specifically the King's Chamber, the antechamber, and the plug blocks located here, which were originally housed at the top of the shaft here, as you will see in just a moment. And if you're new to the channel, I highly recommend the playlist, all episodes starting from the beginning, because you have a lot to get caught up on. And I'll be referring to information in today's episode that was already explained in episode 45, 60, 74, 79, 80, 82, 92, 100, 102, 106, 108, 109, and 117. And I have already created a playlist with all of these episodes focusing on the function of the Great Pyramid so you can get brought up to speed, as I am not going to re-explain material that has already been presented. So, as the reaction sequence began, the King's Chamber, here, was filled with sulfur dioxide gas, and the contact process chamber was filled with water. This priming mechanism was precisely timed to occur in conjunction with the strategically timed lightning strikes that were being produced by the cumulonimbus cloud generation system of the Giza Plateau, which will be coming up soon. And when lightning struck the top of the Great Pyramid, the electric field permeated the limestone body of the structure, a dielectric material with the capacity for storing these fields. And the electric field energy was concentrated primarily within the areas surrounding the sulfur furnace chamber and the acoustic catalyst antechamber, as you can see here from episode 109, presenting the study showing the ability of the Great Pyramid to focus electric fields inside of these chambers. But remember, these reaction chambers were not made from limestone. They are constructed from red granite, which is also a dielectric material with the capacity for storing electric fields. But it has an even higher dielectric constant and thus capacitance than limestone, which has a dielectric constant of 6. But red granite has a dielectric constant of 9. So it has an even higher threshold for the storage of electric fields. And we know that red granite contains a very specific type of material, crystalline quartz. And as presented first in episode 79, I will quote here, "When quartz crystal is subjected to an electric field, a strain proportional to the electric field will be generated. This phenomenon is called an inverse piezoelectric effect. And this inverse piezoelectric effect produces vibrations within the quartz crystal that generate ultrasound waves. The distribution of electric fields from lightning through the limestone core into the red granite dielectric material of the furnace and catalyst antechamber within the Great Pyramid is how the acoustic properties of this structure were activated via the inverse piezoelectric property of the quartz crystal. And I presented in episode 100 how those ultrasound waves can be used as effective catalysts to create chemical reactions, a field now known as sonochemistry. And I will quote here from this article entitled Sonochemistry, Science and Engineering. Sonochemistry is the use of ultrasound to enhance or alter chemical reactions. Sonochemistry, in the true sense of the term, occurs when ultrasound induces true chemical effects on the reaction system, such as forming free radicals, which accelerate the reaction. However, ultrasound may have other mechanical effects on the reaction, such as increasing the surface area between the reactants, accelerating dissolution, a factor that will be relevant today, and or renewing the surface of a solid reactant or catalyst. So these ultrasound waves are an extremely powerful tool for producing chemical reactions, specifically via a phenomenon known as acoustic cavitation. As stated here in this article entitled Sonochemistry, Uses of Ultrasound in Chemistry and Related Disciplines. The term sonochemistry is used to describe a subject that uses sound energy to affect chemical processes. This terminology is in keeping with that of the longer established methods that use light, photochemistry, and electricity, electrochemistry, to achieve chemical activation. It might be argued that a more accurate description of the subject would be cavitation chemistry, since the majority of the applications rely on the energies generated by acoustic cavitation. However, sonochemistry is the established term, and certainly over the last few years, giant strides have been made in the subject. Gone are the days when sonochemistry was considered to be a quote-unquote black art, and simply a method of initiating intransigent reactions, particularly those who depend on the activation of metallic or solid reagents. Sonochemistry has moved a long way since its beginnings in the 1940s and 50s, through its renaissance in the 1970s, to where it now stands, a major new technology available to scientists from a wide range of disciplines. This mechanism of sound-catalyzed chemistry, the so-called black art, takes us full circle to the first slide that I ever made for a Land of Chem video, presented in episode 1, explaining the play on words that is the title of my book, The Land of CHEM, as in the Land of Chemistry. As you can see here, the word chemistry derives from the word alchemy, which is derived from the ancient Egyptian name of Egypt, Khem, chem, meaning blackness. Therefore, alchemy can be seen as the Egyptian art, or the quote-unquote black art. So this black art of ancient alchemy, utilizing sound as an acoustic catalyst for sonochemical reactions, was being performed as these electric fields were concentrated inside of the sulfur furnace and antechambers of the Great Pyramid to facilitate a reaction between the sulfur dioxide being produced in the furnace chamber and the oxygen from the atmosphere being drawn into the chamber through the air shafts. And as those gases were pulled through the red granite acoustic catalyst antechamber through the 4 grooves in the southern wall that you can see here, as explained in episode 100, they were concentrated in the area above the 3 red granite slabs and exposed to ultrasound energy. And these ultrasonic waves were reverberating through the chamber, being produced by this electric field-induced inverse piezoelectric effect, beginning to catalyze the reaction between sulfur dioxide and oxygen from the air to produce sulfur trioxide, as you can see in the chemical equation here. But there is a brilliant mechanism of operation embodied within the operation of this chamber, whereas the sonochemical reaction would not convert all of the sulfur dioxide into sulfur trioxide, as the final reaction would occur in solution via acoustic cavitation within the contact process chamber. So we have here the sulfur dioxide and oxygen being pulled through the antechamber. As explained in episode 80, why is the grand gallery slanted? Flowing through the antechamber here, being partially catalyzed by ultrasound waves to produce a mixture of sulfur dioxide and sulfur trioxide, which are then pulled through the antechamber into the contact process chamber. The water level is then raised inside of the chamber, bringing the water into contact with the two reactant gases, which will produce a series of chemical reactions. First, the sulfur dioxide will dissolve into the water more efficiently than the sulfur trioxide, producing an aqueous solution of sulfurous acid. That sulfurous acid is then immediately further oxidized by the air in the chamber, as explained here. Sulfurous acid is a weak acid. It changes to sulfuric acid on exposure to the atmosphere via this chemical reaction here, showing the sulfurous acid reacting with oxygen to produce sulfuric acid. So then within the water-filled contact process chamber, the oxidation of sulfurous acid is catalyzed by acoustic cavitation from the ultrasound waves emanating from both the antechamber up here and the red granite plug blocks down here in their original housing at the top of the shaft. Following this equation here, again, sulfurous acid being oxidized by oxygen into sulfuric acid to produce the solution of sulfuric acid within the contact process chamber. And according to the conventional archaeology, this was the position of the red granite blocks in their original housing at the base of the grand gallery before they were pushed further down the shaft. And these red granite blocks would have also been affected by the electric fields being introduced into the pyramid, activating the same inverse piezoelectric ultrasound production as within the antechamber, sending acoustic waves up through the solution to induce this acoustic cavitation oxidation reaction. And I had a conversation with a mechanical engineer during my last tour when I explained my hypothesis of this mechanism, and we agreed that these red granite plug blocks may have also functioned as a multi-phase emergency pressure release mechanism, so that if the pressure within the contact process chamber ever got too high, it would force these plug blocks to break loose of their housing, pushing them further down the shaft, thus relieving the pressure inside of the system and preventing catastrophic destruction of the entire pyramid structure. So now, back to the chemistry. Experiments have been done that prove that this reaction, the acoustic cavitation oxidation of sulfurous acid into sulfuric acid, is absolutely possible. As you can see here, catalytic oxidation of sulfur dioxide by oxygen in an aqueous solution of sulfuric acid in the presence of bivalent manganese ions under ultrasound irradiation. As stated here in the abstract, ultrasound irradiation is shown to cause oxidation of sulfur dioxide by oxygen in an aqueous solution of sulfuric acid containing manganese ions as a catalyst with an energetic yield typical for chain reactions. And I'll be getting to these metal ions in an upcoming episode regarding the missing components from within the Grand Gallery. But this multi-stage intermediary chemical reaction sequence of first dissolving sulfur dioxide to create sulfurous acid, then further oxidizing it within the chamber to produce sulfuric acid, and finally dissolving the remaining sulfur trioxide into a solution of sulfuric acid would happen almost instantaneously within the chamber, as the sulfur dioxide more easily reacts with water and would immediately dissolve into solution and oxidize into sulfuric acid. So essentially, the sulfur trioxides generated in the antechamber are being dissolved into a solution of sulfuric acid, a much more manageable reaction than dissolving them into water. And this is exactly what we do today in the modern contact process, where the sulfur dioxide generated in the furnace chamber here is reacted with oxygen within a catalyst chamber, and the sulfur trioxides are then dissolved into sulfuric acid to produce oleum, and then further diluted to render the final solution of sulfuric acid. And I showed in episode 77 a comparison between modern and ancient alchemy. There is nothing new under the sun, one of my favorite episodes ever produced here on this channel. How the chambers of our modern contact process emulate the ancient reaction chambers of the Great Pyramid, with the King's Chamber featuring both of the air shafts, otherwise known as the sulfur furnace here, the antechamber or acoustic catalyst chamber here, the grand gallery or the contact process chamber here, and the Queen's Chamber or dilution and extraction chamber here. And don't forget, as shown in episode 82, the reaction chambers of the Great Pyramid were coated with a chemically resistant coating compound to prevent any corrosion inside of the system. As you can see here, from the Queen's Chamber in 1978, Dr. Patrick Flanagan asked the Arizona Bureau of Geology and Mineral Technology to analyze a sample of the salt found coating the Queen's Chamber. They found it to be a mixture of calcium carbonate, limestone, sodium chloride, salt, and calcium sulphate, gypsum, otherwise known as plaster of Paris. And here, in an excerpt from Zahi Hawass on the restoration of the Great Pyramid, the walls of the Grand Gallery were found to be covered with up to 2 centimeters of salt. The walls of the Grand Gallery were cleaned of this salt residue. And in this image, you can see a carving of a calcium sulfate anhydrite kiln carved into a piece of the same material. And this is exactly what the coating looks like inside of the Great Pyramid. And this is why it works, as stated here. When reacting a block of solid calcium carbonate, limestone, with dilute sulfuric acid, solid calcium sulfate is produced, which is deposited on the surface of the calcium carbonate block. So here we have a solid deposit of calcium sulfate being formed on the surface of the limestone. The calcium sulfate is insoluble in dilute sulfuric acid, and so you end up with calcium carbonate limestone coated in a layer of calcium sulfate, which is exactly what was discovered inside of both the Queen's Chamber and the Grand Gallery. And this calcium sulfate stops the acid from getting at the carbonate and so stops the reaction. So during the first activation of the Great Pyramid, the inaugural production run created an insoluble, chemically resistant coating compound of calcium sulfate salt that protected the reaction chambers permanently from any further corrosion damage. So now I'll put in some clips so you can see the acoustic catalyst antechamber and the contact process chamber for yourself, both of which still show evidence of this oxidation reaction to create the final sulfuric acid product. You can see inside of this chamber, as with in almost all areas of the Great Pyramid, there is pretty significant oxidation here. You see there? And you see that all throughout the Grand Gallery. So again, we're taking the same passage that those gases would have flown through, and this is a passage that was excavated around the antechamber. And you can see here, this is where those gases would have dropped down. So this is also in the antechamber here. This is looking back to where we just were. You can see those grooves on the other side of this stone partition. The gases would have flown down through here, passing through into the contact process chamber. And as I mentioned before, this whole area here is patchwork. This was originally all eroded out of the structure and has been patched with modern concrete. As I showed before, the patch on the lower portion of the antechamber. So now we move here into the contact process chamber, and you can see all of that oxidation on the upper point of the tiered vault system. And bear with me, and I will take you in a journey down through this chamber as we proceed towards the extraction and collection chamber and the subterranean pump system in just one moment. And we're back. Here, looking down into the depths of the contact process chamber. And you will notice that the entire inside of this chamber looks like it's been heated to an extremely high temperature. An indication of the exothermic reaction that was occurring inside of this chamber. The dissolution of sulfur oxides in water producing sulfurous and sulfuric acid is an extremely exothermic reaction. And in one moment, we're going to be crossing the threshold here into the antechamber, leading into the furnace chamber. So the lights are back on. We are here around 4 o'clock in the afternoon. Much less people on the Giza plateau. Ascending the staircase into the contact process chamber of the Great Pyramid.
Bunun bir de inişi var.
And you can see here that they do have electricity wired into the light system, which is now working today. All right.
Devam ediyoruz yukarıya.
Haydi bakalım.
Go. And let me get out the light here. Ooh. Here we go. There certainly looks like there's some concrete or plaster in through here. See, there's remnants of mortar here. And look here. This layer of material, this red material here. Coating material. Huge patch right here. Look at that. And this is leading into the entrance of the extraction chamber system.
Oh my gosh.
Okay. And I'm glad they have the lights on. So that's most likely some modern concrete here. This is patchwork here. Modern patchwork. Now looking back down into the descending passage. This patch here looks to be exposed limestone, and then you can see the elevated area with the coating. Alright, so now we're going to ascend into the contact process chamber. And look at how red it is. I hope you guys can see that on the camera. How red the interior of this chamber is. Look at that red coloring all in through here. Look at the color of this part here. It's red all in through here. Alright, ready?
I'm ready. Yeah, the big.
Water. Okay, go ahead. And let me tell you, it is awesome inside of here today. Almost no people. Nice and cool. Look at all those chisel marks going along this part here. It almost looks like there was something installed on this level here. And shine the light right here with that. So this part here, it almost looks like there was a bar or something installed all the way down here. And look at those chisel marks. As you can see here, as we move up this direction, this is pristine. This part of the channel here, to the left of the chisel marks, this area here, we'll get a little closer to this. Move up just a little bit. So there may have been something fitted into that area that's been chiseled out of there. You can see the chisels at the top. In this area, so this is the bottom of the tier here. But you can see there's a channel right above it here. Alright. Let's see if it's on the other side. Yep. You
see that channel running down that same tier. And then the chisel marks start there. And the big chiseled out patch there. Running all the entire length of the chamber. So now we're going to look at these. And this material here is patched. This pink stuff. So this has all been patched up. Yeah. Thank you. And over here on the left, look at, and you can see the patched area here. This is all patchwork here. Certainly looks like some iron oxide right there.
Okay.
Oh, short round.
All right.
Looks like some iron oxide. These housings. And some of them have been filled in, patched over. You see the material that fills out the hole here. So that's all been patched up. And you can see here, running down along the bottom, this is a conduit for the electricity. This is for a wire. There's a wire running in here, connected into the electrical system. That's powering these, which are, thankfully, again, all this is patched here. All patched up. Same over on this side. So this is all a big patch here. This appears to be original limestone. And then this here is the ancient mortar, the coating compound that covered up the limestone. And you can see how, if you were here in person, you can see how stained that was. So this is exposed limestone here. This is a piece of the coating. See that? Pretty crazy. Alright. Alright, so here's a section. See this stained section here? This is all still covered in coating. This part here with the black drip stains on it. And exposed limestone. Coated, exposed. And here we go, through the antechamber. And I'll be doing a very special episode on the antechamber of the Great Pyramid for episode 100 here on the land of Chem. And you can already hear that within this chamber the acoustic properties are the most magnified in the entire structure. So we have these 4 grooves. This is a patch here. This is restoration work. There were originally some beams of stone here. And you can see the remains of one here that have been knocked out of place. And there were 3 large slabs of granite, one here that went all the way to the floor. In these housings, okay, so you imagine this piece comes out several inches, and the piece of granite was locked into place in between these two bilateral housings. So a huge piece of granite here, piece of granite here, and then a piece of granite here. But this piece did not go all the way to the floor. It stopped right here. And as I explained before, dropping the water level in the contact process chamber, we draw the gases from the sulfur furnace chamber up through these grooves passing over and then falling down into the contact process, being drawn into the contact process chamber. Man, that's an awesome shot. All right, so now into this small intermediary chamber. Listen to that. This area of the Great Pyramid has by far the highest amount of acoustic amplification. And I'll be right back. All right, so now we'll begin our descent back down through the contact process chamber. And on the ascent, man, I showed you some of the most anomalous details that I've ever recognized here inside the structure. The intense staining on the coated original portions of the walls. The housings that appear to still have traces of metal oxides. The patching, the coating compounds, the oxidation in the ceiling, which you can see above us. Look at this piece right here. Look at that black staining there on that tier. I mean, this entire structure looks like it's been baked on the inside. Extremely high temperature exothermic reaction, dissolving sulfur trioxide gas into water produces an extreme amount of heat energy. Hence the volume of this massive chamber. As explained in the episode Why is the Grand Gallery Slanted, it prevented the whole thing from boiling over out of control. The more water you have, the smaller amount of sulfur trioxide, the more you can control the reaction. If you have a significant amount of sulfur trioxide and a tiny amount of water, the solution is going to boil over out of control. So these two things were mixed gradually with an excessive volume of water, producing a very dilute solution of sulfuric acid that could then be concentrated if needed, depending on the application. Quite a different experience exploring the Great Pyramid with the lights back on. Of course, as always, completely soaked because it is hot AF inside that King's Chamber, but much more tolerable. Very few people in here today and quite an amazing experience. So now we're going to continue with the exploration of the Giza Plateau. Yalabina.
All right, and for the initiates of the Land of Chem members only channel, the unreleased footage from my expedition to the Hill of Tara in Ireland is now available, featuring the Stone of Destiny. This was an absolutely spectacular, breathtaking adventure, and in next month's episode, I will finally reveal my hypothesis about the function of the Osiris shaft on the Giza Plateau. And if you want access to the exclusive research and unreleased footage that will never be presented on the public channel, join the members only section, link in the video description below. All right, everyone, that is it for today's video. This was episode 120, Ultrasound Catalyst inside the Great Pyramid of Giza. I really hope you enjoyed today's video, and in this week's Sunday site visit, another Land of Chem exclusive that I can guarantee you will not see anywhere else. from inside of the underground mining tunnels below the Giza plateau known as the Tomb of the Birds. If this is the type of content you're interested in regarding the technology of an ancient civilization utilizing physics and chemistry, and the function of the Egyptian pyramids and other ancient structures from across the world, this is the channel for you. So please subscribe to the Land of Chem here on YouTube. Don't forget to click that little notification bell so that you do not miss the new episodes that premiere twice per week. Please like, comment, and stay tuned if you want to help support the channel. Check out the Land of Chem members only channel, link in the video description below for exclusive research and unreleased footage that you will not see anywhere else. If you want to pick up a copy of the book or grab some merch, check out thelandofchem.com. If you want to follow me on Instagram, my handle is @thelandofchem. Also, don't forget, please go subscribe to our 2 new channels here on YouTube, Egyptian Trash Cats and Egypt Eats. Ladies and gentlemen, as always, thank you all so much for the support. I think that's it for today's episode. So I will see you next time. Yo, are you still watching this? Please subscribe to the Land of Chem here on YouTube and click that little notification button. New videos coming out every single week. And check out this other episode. Come on, do it. Do it now.